We are going to graph linear functions today, and a linear function is something that can be written in the form of f of x equals mx plus b, where x is the independent variable and m and b are constants. What that means is that m and b are going to have numbers. X is what we can change and what we can plug different numbers into. When we graph anything in this form of f of x equals mx plus b, we're going to have a straight line. So example one, we're going to be given a chart of numbers, so a t-table, and need to determine whether each set could represent a linear function. And the way that we do that is we find the common difference. So how do I get from 0 to 2, 2 to 4, and 4 to 6? Well, looks like we add 2 here, add 2 here, and add 2 here. So that's good. We want a common difference. And then from -1 to 2, that would be adding 3. 2 to 5 would be adding 3. And 5 to 8 would be adding 3. And that's good as well. That's a common first difference. So both have the exact same change on the top and the bottom. So we can go ahead and say, yes, this would represent a linear function. For part B, we have to do the same thing. From -1 to 2 is going to be plus 3. 2 to 5 is going to be plus 3. And 5 to 8 is going to be plus 3. Down here, from 0 to 1 would be plus 1. 1 to 3 would be plus 2. And 3 to 6 would be plus 3. So because that bottom, that f of x row, is not the same distance apart, then we have to say, no, this is not going to be a linear function. Then we're going to talk about slope. And slope is rise over run, or the change in f of x over the change in x. So basically, the change in f of x, or the rise, is going to be your up or down. And then the run, or the change in x, is going to be your left or right. Okay, so up and down over left to right. And we need to graph each line. For part A, it's a line with slope of 2/3 that passes through the point 1, 1. So we have to graph that starting point of 1, 1. So that's there. Then we are going to do the slope, and they said the slope is 2/3. So 2 over 3, this means rise over run. So from that point, I have to rise 2 and run 3. And since everything's positive, that means we're going to go up and we're going to go to the right. So up 2 would put us here. And then we have to go over 3. And that would put us right there. That's our new dot. And it says the line with slope of 2/3 that passes through this point. So then we can go ahead and connect our dots to make our straight line. For part B, the slope is -1/3, and it's going to pass through -2, 3. So go to -2, positive 3, and put a point. And our slope is -1/3. So our rise is -1. So that -1 rise means I'm actually going to go down 1. And then the 3 is run. That's a positive 3. So I have to run 3. 1, 2, 3. So that would be here. And we connect our two dots to make our line. And we are done. Y-intercept is the y-coordinate of a point where the line crosses the y-axis. And the x-intercept is the x-coordinate of a point where the line crosses the x-axis. So y-intercept crosses the y-axis, x-intercept crosses the x-axis. So if you think about a point that's on the y-axis, you don't have to go over anything, but you would have to go up or down. So let's just say 2. So the y-intercept of that point is actually 2 because it's on the line at positive 2. For the x-intercept, if we thought about a line, maybe we have to go over 5, but then we're not going to go up or down anything. We're going to sit on that x-axis. So our x part of that ordered pair would be our x-intercept. In that case, it would be 5. So what I want you to notice is that when we are finding the y-intercept, our x is 0, and when we're finding the x-intercept, our y is 0. So opposite letter is 0. So for this example, we have to find the y-intercepts of this equation and then graph. So if I want the y-intercept, I'm going to plug in 0 for x. 2 times 0 is 0, so that's gone away. I just have negative 3y equals 12. Divide both sides by negative 3, so y would give me negative 4. So my y-intercept is negative 4, and I can put a point there on the y-axis. Then I have to do the same thing, but the 0 is going to go in for the y. So I'm going to have 2x minus 3 times 0 equals 12. So 3 times 0 is 0, so that's gone. So I just have 2x equals 12. And then I would have to divide by 2, and 12 divided by 2 would be 6. So my x-intercept is 6. And so on the x-axis, we put a dot at positive 6, and it says, and then graph the line. Well, once we have those two intercepts, that's all we need to draw a line, connect them, and we are done with that one. Slope-intercept form is y equals mx plus b, because m is the slope and b is the y-intercept. So we know what the slope is, we know what the y-intercept is right away from looking at that equation. That's why it's called the slope-intercept form. For example 4, we have to write each function in that form and then graph our function. So basically what we have to do is solve for y. So I have to move that 2x. It's positive right now, so I'm going to subtract 2x from both sides. I'm going to bring down this, but I'm going to notice there's a negative sign in front of that y, so I have to be careful. And I can't do anything with 9 minus 2x. They're not like terms, so I'm just going to write 9 minus 2x. Then that negative sign is like a negative 1, so I'm going to divide both sides by negative 1. That leaves me with a positive y, a negative 9, and a positive 2x. I am going to rearrange that, so 2x minus 9, so that it's in the form of y equals 2x minus 9. Now to graph that, our y-intercept is negative 9, so our b is equal to negative 9, and our slope, our m, is equal to 2. So we're going to start with that y-intercept point at negative 9. And our slope is 2, so we're going to go up 2 and over 1, since 2 written as a fraction is 2 over 1. And then we can connect those two, and we have our line. For this one, we have to solve it for y again. So I'm going to minus 30 from both sides. And 5x minus 30 we can't do, so I'm just going to write 5x minus 30 equals, the 30s are canceled, so just the 15y is left. And then I have to divide both sides by 15. 5 divided by 15 doesn't simplify down to a whole number, but I can reduce it if you think about it as a fraction. 5 over 15 would be 1 over 3x. And negative 30 divided by 15 would be a negative 2. And then we would just have our y left. So I am going to flip this around so it's y equals 1/3 x minus 2. Our b is negative 2, and our slope is 1/3. So we start with a dot on the y-axis at negative 2. And our slope is 1/3, so I'm going to go up 1 and over 3 and connect those dots. So for example 5, determine if each line is vertical or horizontal and then graph it. So this one, y equals negative 5. So if you think about a t-table, that looks like that, y is -5. So no matter what I have in that x column, our y is going to be -5. So I could have 1, 2, 3, 4, whatever. So if I were to graph those, no matter where I go on the x-axis, I have to go down to -5. So what is that line going to look like then? It's going to be a horizontal line. So anytime you see y equals just a number, it's going to be a horizontal line going through whatever number that is on the y-axis. So if I told you y equals 8, then you would go to 8 on the y-axis and draw a straight line going across right here. Okay, so anytime it's y equals, that's what kind of line you're going to have. Now, since that one's horizontal and it was y equals a number, this one's x equals a number, so this one's going to definitely be vertical. And no matter what our y value is in our t-table, our x is always going to be 2. So no matter what, we're always going to go over to x is 2, and then we can go up or down wherever we want. So we can have points all over here, so we connect them to make our straight line. So x equals a number is going to go through that number on the x-axis.